Okay, so one, sorry I couldn't be in class today, not feeling too well at all, splitting headache, but I thought I'd still help you guys out in figuring this conservation of energy calculations. So we looked at this problem yesterday, but let's actually go through it in depth. So, first things first, let's start our writing process. It says Tarzan swings down from rest on the end of a vine from a tree limb 4 meters above the ground. How fast is Tarzan going or moving when he reaches the ground? So one, you have to think this is conservation of energy, which states what? Well, basically it says is that your initial, this is horrible writing, but that's okay. Your initial mechanical energy equals your final mechanical energy. And if you recall, mechanical energy is the sum, it's the total amount of kinetic energy and potential energy. So specifically, we're looking at the initial kinetic plus the initial potential. And that's going to equal your final kinetic energy plus your final potential energy. These would have I's and these would have F's, but again, this writing utensil thing that let me do on a computer is not working too well. Regardless, how do I set this up? Well, basically, I need to write the equations for kinetic energy and potential energy for both sides, but I need to label them as initial. So, I'll have 1/2 times mass. Now, your mass is constant. It never ever changes. So, therefore, I don't need an initial or a final mass. 1/2 times mass times initial velocity squared plus mass times gravity times your initial height. That's going to equal 1/2 times mass times final velocity squared plus mass times gravity times your final height. So now let's read the problem and try to figure out what do I have, because I only gave you one number that you actually see. What is that one number? It says 4 meters above the ground. So you got to think, what is the problem doing? So you have a person up in a tree, on a tree limb, 4 meters above the ground. So they started 4 meters above the ground and they're not moving at all. So your initial velocity is 0. This thing will write. Oh, it's messing up big time. It's 0 meters per second. That's your, ooh, never write units. Hold on, I apologize. You're not supposed to have units for 0. That's a really huge eraser. Okay, we'll write that again. Your initial velocity, if this thing can do it, is 0. Your initial height is 4 meters. Okay, then what happens? You swing down to the ground. So you're trying to find, because that's what you're looking for. You're looking for your final velocity. That's your question mark. And your final height, well, if you swung down to the ground, your final height would be 0, because you're on the ground now, and that was 0. So with that being said, if the initial height is 0, 0 squared is 0, 0 times anything is 0. So all of this right here, that's 0. Your final height is 0. Well, again, 0 times anything, 0. So now what are you left with? Now here's your equation that you're left with. And this doesn't always happen, but the more zeros you get, the easier this is. So this says mass times gravity times height, initial height, equals 1/2 times mass times final velocity squared. Sorry if I didn't mention this. You should have this packet in front of you. Follow along and write what I write on your packet. That would be the smart thing to do. If you need to pause the video, pause it. If you need to go back, go back. Okay, my goal is to get final velocity by itself. How am I going to get final velocity by itself? Step 1, I'm going to get the half over. How? I'll multiply both sides by 2. That will get rid of the half over here and bring it to the other side. So now I have 2 times mass times gravity times the initial height equals mass times final velocity squared. Next, I got to get final velocity squared by itself. How? divide both sides by mass. Goodbye mass. Goodbye mass. I have mass over here, mass over here. Also, interesting fact. If every single equation has the exact same variable, notice, every single equation has mass, they all cancel out. Just get rid of it. I could have gotten rid of it at the very beginning if I really wanted to, but the mass goes bye-bye. You'll never, ever, ever have to deal with mass, ever. So now that gives me 2 times gravity times the initial height equals final velocity squared. Last step, how do I get final velocity? I square root both sides. So my final equation is the square root of 2 times gravity times the initial height. Now again, you have to do these letters first. You have to manipulate. You have to solve using nothing but variables first. Because like I just said, with the mass, you don't even have that number. So you can't really plug your numbers in first if you don't have all the numbers. You have to gain practice manipulating just variables. Now that I've isolated the variable I want, final velocity, I can just plug numbers in that I do have. So that would be the square root of the product, 2 times 9.8 meters per second squared, because that's gravity, times the initial height, 4 meters. So when I do the square root of 2 times 9.8 times 4 meters, I get, looking off here to the side, there it is, roughly 8.9 meters per second. 8.9 meters per second. And there you go. There's the first one. We'll try to do 2 more of these. We'll see how long this goes, though. I don't want to spend way too much time. 2. Calculate the height of the initial drop a roller coaster must have in order for the riders to travel up the next hill of 18 meters with a speed of 12.4 meters per second. Assume the coaster starts from rest at the top of the initial hill. So if it helps draw a picture, here's my roller coaster. Okay, I want to figure out how high this is. What is this height right here? I know the height of this hill is 18 meters. And I know when I'm at the very top of this hill, the roller coaster is going 12.4 meters per second. I also know at the very top of the first hill, the roller coaster is going 0. It's not moving. So my goal is to figure out what is this height here. If that's the case, let's write my equation. 1/2 times mass times the initial velocity squared plus mass times gravity times the initial height equals 1/2 mass times final velocity squared plus mass times gravity times final height. All right, let's see if there's any zeros. There is. We kind of talked about it already. It says you started from rest. So that means this whole thing right here is 0. Yay. The initial height is what I'm looking for. If it helps, if you need to write stuff off to the side, like the initial velocity is 0, that's fine. The initial height is what I'm looking for, because it says calculate the height of the initial drop. The final velocity, which is the velocity at the second hill, is 12.4 meters per second. And the final height, the height of the second hill, is 18 meters. So unfortunately, the only thing I can cross out is this 1/2 mass times initial velocity squared. So it's not that this becomes any harder, it's just basically a little bit more manipulation. Now, again, a shortcut. Because everyone brought mass to the party, you can get rid of mass. So if you really want to, go ahead and just write this. Gravity times initial height equals 1/2 times final velocity squared plus gravity times final height. So again, because everybody brought mass to the party, mass goes bye-bye. Note, I cannot do that to gravity, because yes, there's gravity here, there's gravity here, but there's no gravity in 1/2 final velocity squared. So you can't cross out the gravities, okay? Again, everything has to bring the same thing to the party. everybody brought mass to the party, so mass is gone. Bye. My goal is to get the initial height by itself, so that's going to be easy manipulation. Divide everything by gravity. So simply, I just divide everything by gravity. Boom. Boom. And I get the following. Gravity's here, cancel though. I get initial height equals 1/2 times final velocity squared plus gravity times final height. That's its own unique answer. Divide by gravity. Again, you can't just cross out gravities because not everybody brought gravity to the party. So there's no gravity here, so you just can't cross out gravities completely. Do not do that. So now I can plug in my numbers. 1/2 times final velocity squared. So that would be 12.4 meters per second. And I'm going to square that. So I'll put that in parentheses. There we go. Plus gravity, 9.8 meters per second squared, times the final height, 18 meters. Okay. And I'll put it all in the calculator. Here's how I would put this in the calculator. I personally would square 12.4, so I would put 12.4 squared times 0.5, get that number, and then put plus parenthesis 9.8 times 18, close parenthesis, get that answer. So that'll give me an answer, and then I would divide that by 9.8 meters per second squared. And if you do that, try putting this in your calculator, you should get an initial height of roughly 25.8 meters. If you want to round that to 26 meters, more power to you. You do you. You do you. And again, it makes sense. The initial height should be of the first hill should be bigger than the second hill. So that makes sense. Let's do one more, and then you guys are on your own. What's my time, by the way? 12 minutes. Okay, way too long, but that's okay. It says Justin throws a ball straight down from a height of 2 meters. If the ball strikes the floor at a speed of 7.5 meters per second, what is the initial speed of the ball? Now, this is going to be the toughest one yet, just because of how we have to move things around. Step 1, always write your equation. 1/2 mass times initial velocity squared plus mass times gravity times initial height equals 1/2 mass times final velocity squared plus mass times gravity times final height. All right, let's see if there's any zeros. Justin throws a ball, which is what I'm trying to find. What's the initial velocity? So initial velocity, question mark. From a height, initial height of 2 meters. If the ball strikes the floor of a speed, final velocity, it hits the floor at 7.5 meters per second. What's the initial speed? So it hits the floor. The floor is your final height, and that would be 0. So that goes bye-bye. That's 0. Everybody brought mass to the party, so bye mass, goodbye mass. And so I'm left with 1/2 initial velocity squared plus gravity times initial height equals 1/2 final velocity squared. All right. I want to get initial velocity squared by itself. Step 1, I gotta bring this gravity and initial height to the other side. What do? It says plus gravity and initial height. So how do you bring it to the other side? Please remember, one of the most common mistakes, I hear this all the time, especially from my seniors who are in physics. Oh, you divided. No, you don't divide. It says plus right here. To bring over a plus to the other side, you subtract it from both sides. You want to subtract that. Oh no, my pen died. Did it really? Is it dead? It's dead. Great. All right, so let's see if I can do this. I gotta handwrite it like this. This is gonna be super horrible. Gravity times initial height. Oh man, that's horrible. I am so sorry. Okay, this all goes bye-bye. Cuckoo, that's gone. Okay, let's see if I can get this to work again. Nope, it's dead. What if I turn it off and turn it back on? This thing has like the lowest battery ever. Cheapest thing. Alright, let's see. Maybe I can get... Okay. Whew. Let's see if I can get it done in a couple seconds. Here we go. It gets right. So that gives me 1/2 times initial velocity squared equals 1/2 times final velocity squared minus gravity times the initial height. Next, I got to bring over the 2. How? I multiply both sides by 2. So I want to do the quantity times 2. So these go bye-bye, and I'm left with initial velocity squared equals, and if you want to distribute this too, you can. So 2 times 1/2 times final velocity squared is just final velocity squared minus 2 times gravity times initial height. I did what's called distribute the 2, meaning I multiplied everything in the parentheses by 2. If you haven't learned that in Algebra 1 yet, shame. Shame, shame, shame. No, it died again. Okay, turn it off, turn it back on. I'm so close to being done, so close. How do I get the initial velocity by itself now? Square root both sides. And so finally, I get initial velocity equals the square root of final velocity squared. No, that does not just automatically cancel. Minus 2 times gravity times initial height. The reason why this square and this square root don't cancel is because this is a quantity. Now that I got that, plug all my numbers in. Final velocity, 7.5 meters per second. Square all that. Minus 2 times 9.8 meters per second squared. That's just the units. So this squared, I actually have to square 7.5. And this would be 2 times 9.8 times the initial height, 2 meters. How would you put this in your calculator? Personally, here's how I would do it. I would do 7.5 squared. Then I would hit minus parenthesis 2 times 9.8 times 2, close parenthesis, get an answer. Then I would either write that number down, or I would hit square root, second square button, which gives you the square root, second answer, which is the minus symbol, or negative symbol. Anyways, if you put all this in the calculator, you'll get an answer of roughly 4.1 meters per second. So again, I encourage you to try doing this. Last one, actually that was our last one, but for what I want you guys to do now for the rest of the bell, try the rest of these. I'm going to give you the answer to number 4 to see if you did it right. The answer to number 4 is 4.1 meters. Sometimes if you know the answer at the beginning, it helps you figure out how to get to the answer. Here's the only big hint you really need for this, because we haven't really talked about this in a long time. When you're at the maximum height, whenever you throw something up in the air or whenever you do the maximum height, your final velocity is 0. Again, when you're at the maximum height, the final velocity is 0. So again, try doing this one. Your answer should be 4.1. Continue until it's the end of the bell. FYI, I want you to rip off the very last page, which has questions 7 and 8. Those are your homework questions. I expect to see those Wednesday when I come back. So turn those in Wednesday. All right. Thanks, everyone. If you have any questions, ask people in class, because I'm not there to answer them. Bye.